So, welcome to lecture number 60, case studies in object oriented programming. So, we had seen two case study in C++ and two case studies in Java, alright. So, in this lecture what I can do, I will talk about Python, right. So, Python, I have chosen the problem of image classification, right, the digital image classification, because the whole world is behind the AI now, right. So, we will see some of the examples of the neural networks, right. So, how to use these neural nets using Python, right. So, I take Python over here. So, the main objective of this case study is to create a tool to classify the images, right, into predefined categories, right. Suppose if you are given an image, so let us say the image contains cats and dogs, right. So, you have several images, right, it contains one image cat, another image dog, right, cat and so on. So, you have to do the classification. So, this is cat, this is dog. So, that is called the classification, alright. So, the predefined categories. So, you call it as a supervised classification problem, right. So, we have a label, right. So, that we are going to train. So, you are going to talk about the train, we call it as a pre-trained model integration, right. So, for this we use ResNet and MobileNet, right. Some of you might have studied, right, the neural nets or deep learning algorithms, right, the ResNet, MobileNet. So, these are all the standard terminology in the deep learning or even the neural network terminologies. Then file handling, we are going to handle the file where we have to load the images, right, and then we have to save the results as well, right. So, this involves future extraction, etc. So, therefore, we have to save the results. Here we are going to have the modular design using the object oriented principles. The use cases are categorizing the product images in e-commerce and identifying the objects in security footage. So, the modules and key components in high level design. So, we are going to have image loader, so which will load and pre-process the images, and when you want to manage the pre-trained models, we have the model manager, and in order to perform the classification and store the results or return the results, we have the classifier, alright. So, the classifier is the standard terminology in machine learning or deep learning, alright. And object oriented point of view, we are going to use inheritance. So, this extend functionality for new models. Then we are going to have file handling, right. So, whatever the predictions that you are having, so that will be saved in a file, alright. So, prediction, this is another key word in machine learning or deep learning, alright. So, whatever the predictions that has come as a output, we have to save it as a file, right, or save them as a file. Exception handling, right. So, this will help you to manage invalid input, right. So, this will manage the invalid input. So, as usual, so the class diagram, the classes that we are going to use, image loader. So, this will handle the images for loading and pre-processing. Then we are going to have model manager. So, for the pre-trained data or pre-trained model, alright. So, for labeling and managing, we use model manager, and the classifiers, right. The classifiers integrate image loader and model manager. So, this will integrate, classifier integrate both, that means image loader and model manager, right, for the final predictions. So, image loader you have, right. So, that will load and pre-process the image, this is overview, and model manager loads and manages the predefined model. So, here you call it as loads the model and inference logic, right, and classifier coordinates the prediction process. So, this is the overview. So, in general you call this as a class diagram. So, let us see this Python code, right. So, you have a class image loader. So, under this you have init, this we had seen before, right, the init method, right. So, this is initializing the class with image path, right. So, that is provided by the user, right, that is provided by the user, and self dot image underscore path, this is storing the path of the image file, right, this is storing the path of the image file. So, this is what we had seen up to line number 6. Now, if you go to line number 8, define load underscore image of self, right, load underscore image. So, this method attempts to load the image, right. So, this method attempts to load the image from the given file path, all right, from the given file path, right. So, that means it is opening the image using, the image is invoking open, right. So, here you have self which is invoking image underscore path. So, you call this as a pillow library, all right. So, this is pillow library, this is pillow library, line number 10. And image is invoking convert RGB, that means it is converting, right, it is converting the image to RGB format, converting the image to RGB format. So, we are using the convert function, right. So, convert you are passing, and in fact, you have underquote you have RGB. So, this ensures the image has 3 color channels, right. So, this is ensuring the image has 3 color channels. The color channels are nothing but red, green and blue, right. The color changes are nothing but the red, green and blue, and you have return image. So, I will come to that, right. If there is an error occurs, right. So, because we are talking about the path and file etc., right, because you are going to load the image from the given file, that is what we had seen for the case of a load image, right. Suppose as usual, if you are not able to open the file or the file does not exist, that means if you are having any exception, right. So, this message will be printed, it is like a e dot what, right, the message will be printed, the error message will be printed. So, now if there is no error, it is returning an image, right. If it can be able to open the file and it is converting to RGB, then it is able to return the file, otherwise it will return none, right. So, this will return none. Okay. So, this is what we had seen up to line number 15. So, next we have pre-processes method, right, pre-process method, right. So, under pre-process, right. So, this prepares the image for use in machine learning models, right. So, this pre-process method, right, prepares the image for use in machine learning models, right. So, mainly we use for deep learning models, right. So, the frameworks like TensorFlow or PyTorch, right, TensorFlow or PyTorch. So, here what it is doing, right, it is resizing the image to 224 by 224, right, whatever be the input, right. So, let us say our target size is 224 by 224, right. So, target size is 224 by 224. So, here you have line number 18, you have resize, right. So, whatever be the input, right, by line number 18, right. So, this will be resized, your target size is 224 by 224. So, that will be whatever be the image that you are giving, that will be resized to 224 by 224, right. And line number 19, so you have numpy NP, right. So, which is converting, right, you have an array of image, that means every pixel the gray level value you are dividing by 255, the meaning is this will go into the range 0 to 1, closed interval 0 to 1, all right. So, this is very common in the deep learning models, all right. So, this is I mean the gray level value, correct. So, which will be convert m cross n image, assume that m cross n image, all right. So, each array elements, right, that will be divided by 255. So, that means assume that you have 0 to 255, right. So, that means we know that the range will be now image underscore array range will be now 0 to 1. So, this is very common for deep learning algorithms. And then finally, you have the numpy which is invoking expand underscore dimensions, right, DIMS. So, you have image array and axis is equal to 0. That means, this adds a new dimension, right, for batch size. This adds the new dimensions for batch size, making it compatible with models expecting your input shapes like, right, batch size, batch underscore size, right? What else? Height, width, right? Width and channels, right? And then it is returning NumPy array. That image array is NumPy array, right? So, this is what exactly, it is nothing but the image loader. This class is considered as, right, or it is called as the image loader class. I hope it is very clear. So, whatever image, first it is converting into RGB, right, and here you have the pre-process stage, right, whatever be the image you have in hand will be resized to 224 by 224, and then every pixels you are converting into 0 to 1, right, by dividing, by normalizing, right. Line number 19 is nothing but the normalization, right, and it is returning this particular case. So, image array with access is equal to 0, right. I hope it is very clear. So, the image loader class that we had seen in the last slide. So, this is handling image loading and pre-processing, all right. So, key features are loading the image using Pillow library, and it is ensuring the image is converted into RGB format, and we have resized, right. So, we resized to 224 by 224 pixels. So, this is mainly for the mobile net, all right. So, why you are converting? You may ask the question, right. So, this is a mobile net features. The mobile net, we are converting any size into 224 by 224, right, in the deep learning mobile net, and it is normalizing pixel value from 0 to 1, right. The range is 0 to 1 that we had seen, all right. And then finally, it is preparing the image for input to the model by expanding the dimensions. So, these are all the key features we had seen in the last slide. And the next one we will talk about the model manager, right. So, we use TensorFlow Keras applications, which is importing mobile net, right. So, the 224 by 224, right. So, the mobile net I talked about this one, right. So, from TensorFlow Keras application mobile net, we import pre-process underscore input, right. So, here you have class model manager, right. So, the init method over here in line number 5. So, this is initializing the model manager, right. So, this is initializing the model manager class and loads the pre-trained mobile net and loads the pre-trained mobile net model, right, and loads the pre-trained mobile net model with ImageNet weights, right. So, here you have the weights. So, weights is ImageNet, right. So, the meaning of ImageNet here, right. So, this is nothing but the model is pre-trained, right, where on the ImageNet data set, right. The model is pre-trained on the ImageNet data set, and then this will be stored here, right. So, once it is done, that is stored in self dot model attribute, right, that is stored in self dot model attribute. And line number 8 you have load underscore model, right. So, the load underscore model, right. So, this returns mobile net model stored in self dot model, right, mobile net model stored in self dot model, right, that is the purpose. And this method is also allowing to access the model instance, right, if needed elsewhere in the program, right. So, these are all the purpose, right. So, this method is allowing to access the model instance if needed elsewhere in the program, right. So, this is up to line number 9. So, here you have predict method, right. The main idea of predict method is to make predictions using mobile net model, right. So, here you have the model that you are explicitly passing, right, and then you have pre-processed underscore image. So, which we know it is nothing but a NumPy array of the pre-processed image, right. So, array m cross n, assume that is m cross n array, right, and then you have let us say process, right. So, the process which is calling the predict, right, the models predict, right, where this is the input image. The model is invoking predict, right, where you are passing the pre-processed image, alright. So, that will be stored in the predictions, right. In the left hand side you have predictions, and then you are returning the predictions, right. You are returning the predictions, right. When you are returning these predictions, so typically you have the probability distribution, right, over ImageNet, right. So, this will have, let us say, 1000 classes, right. So, this is return predictions, all right. So, returns the predictions. So, the meaning of this is the probability distribution, right, over ImageNet's 1000 classes, fine. So, this is what the model manager class is doing, right. So, the purpose of the manager class, so this is managing the pre-trained mobile net model and predictions, that is what we had seen, right. So, the key features were loads the mobile net model pre-trained on the ImageNet data sets, right. So, you have to load the mobile net model, correct, and then so this is handling the pre-processing of inputs using mobile net specific requirements, and it is performing inference to generate predictions for given input, all right. So, this is what we had seen for the case of model manager class. So, I talked about mobile net. Now, you may ask the question, what do you mean by mobile net, right. So, those who have already know deep learning algorithms, so you know that this is a family of lightweight deep neural networks, right. So, this was developed by Google, right, the mobile net that I talked, right. So, in the case of a deep neural network, so this is called as the family of lightweight deep neural networks, right, and then this was developed by Google. And why it was developed? And it is mainly designed for the efficient inference on mobile and embedded devices, right. So, here I am talking about the efficient inference on mobile, right, and embedded devices. So, for this particular mobile net has been designed. So, the main key features are these mobile net uses depth-wise separable convolutions, right. So, you go into the deep learning algorithm, convolution neural network, right. So, just go through that, I am just giving an idea, all right. So, where it is being used. So, in fact, we have used several the inbuilt libraries. So, the key features of mobile net, which is nothing but the depth-wise separable convolutions to reduce the computations and parameters, right. And another key feature is it is a pre-trained model on the ImageNet data set, and it is also providing the state of the art accuracy, the literature accuracy with significantly lower complexity, right. So, many are using, there is a deep learning researchers. So, you can see, I mean, the mobile net is one of the famous architecture, right. So, what are all the applications? Real time object detection, suppose in a video, right, I want to detect a few objects, right, I can use mobile net, and image classification algorithms, right, and transfer learning, right, transfer learning for custom tasks, right. So, I have a pre-trained model, right, assume that it is finding out the cow image, right, it is finding out the cow image, and I have the pre-trained model, correct. So, now I will use it, for example, I have been given the for test case I had been given, right. So, it will detect the object, right, whether the cow present in the image or not, right, or any other classification algorithm. So, the last one, the cow example that I said, it is a transfer learning. So, already I had a pre-trained model, so I can use it for the transfer learning, right. So, the main idea of using mobile net is, so this is ideal for tasks requiring efficiency, and this is also slightly, right, it is fast, right, or more fast or faster than the other nets, right. So, this is ideal for tasks requiring efficiency and speed, and this is widely supported in TensorFlow and Keras, right. So, in fact, we have imported the TensorFlow and Keras, right. So, when I want to use the mobile net, if a first line, if you look, you have TensorFlow and Keras. So, now you have classifier class, right. So, here you have, you are importing image loader from image underscore loader model manager, and TensorFlow, Keras, and applications mobile net, all right. So, these import decode underscore predictions. So, now as usual you have a init method, right. So, the purpose of this is initializing the classifiers, right. It is a classifier class, right. So, this is initializing the classifier class by creating instances of image loader and model manager, right. The instances are image loader and model manager, right. So, what are all the input? Here you have image underscore path, you are passing image underscore path, right. See, this is a path to the image to be classified. So, this path you are giving, so like a file image underscore path, and then you have self dot image underscore loader, right. In the right hand side you have image loader where you are passing this path image underscore path, right. So, this is an instance self dot image underscore loader, this is an instance. So, this is the instance of the path image loader is a class for loading and pre-processing the specified image, correct. So, for loading and pre-processing the specified image, and then you have model underscore manager self dot model underscore manager. So, this is an instance of the model manager, right, model manager class for managing the mobile net model, for managing the mobile net model, all right. So, next one is you have classify method, right. So, the classify method you are loading the image, all right, you are loading the image. If there is no image, like the file does not exist or you are not able to load the image, all right, it is printing the invalid image. Now, we know the load image what it will do, it will convert into RGB, right, it is converting the image into RGB. So, here you have image loader, right, which is invoking load image. So, that means it will open and converts into RGB, right, it is converting into RGB. So, if you are not able to open the image, it will return invalid image. So, up to line number 13 it is very clear. So, line number 19 you have the self, right, image underscore loader. So, that is pre-process the image, right. So, pre-process the image, what is the meaning of pre-process the image? It will resize, we had seen 224 by 224 and normalize the image using the pre-process method, right. So, this pre-process method, so that anyway we had seen. So, resize and do the normalization, right. So, this is available in image loader class, right, or image loader method, correct, image loader method. This is for pre-processed image. Then you have load model, right, line number 16 you have load model. So, the load model fetches the mobile net, right, it is fetching the mobile net, or I can say it is fetching the mobile net model, right, with the help of this load underscore model method of model manager, model underscore manager, okay. So, that will be stored in model, that will be stored in model. So, now you have to make the predictions, alright. So, for that we use predict, right, you have to make the predictions. So, for that you use the predict method and here you are passing model and the pre-processed image, right. So, now here your predict method, right. So, you are passing the pre-processed image, right, and then it will do the predictions, right, and then it is stored in the predictions left hand side. So, what do you mean by prediction? So, it is nothing but the array of size 1000, right. So, this is what I said, array of size 1000. So, which contains the probability scores, right, of the distribution over the image net class. And the next one is line number 19, this is what about line number 18, and line number 19 you have decode predictions, right. So, it is converting the raw predictions into a right, we had 1000, the raw predictions into the top 3 predicted class, right, the top 3 predicted classes, top 3 predicted classes, top 3 predicted classes with confidence score, all right. So, that will be assigned to decoded predictions and that decoded underscore predictions will be returned, okay. So, this is what the classifier class will do. So, the classifier class, right. So, this integrates image processing and model prediction for classification, right. So, mainly the computer vision problem or image processing. So, mainly this is useful for the classification, model prediction for classification. So, the key features, so we combine the image loader and model manager, right, with the help of classifier class, and it is loading and pre-processing the input image, right. It passes the processed image to the model for prediction, and the classifier class decode predictions into human readable labels, right. So, that is what I talked about, right, the top 3, right, the human readable labels. In fact, you had 1000, right, you had 1000 with the probability distribution. So, out of this it will return the top 3 predictions. So, these are all the key features we had seen in the last slide. So, here we are seeing file handling for saving predictions. Here you have class file handler, and this is called the decorator, right. The name of the decorator is static method, correct. So, this decorator indicates, right. So, you are going to define the save prediction method, right. So, the save prediction method, which is a static method, and the static method can be called without creating an instance of the class, right. Without creating an instance of the class, the static methods can be called in Python. And here you have defining save underscore predictions, right, and then you are having predictions, you are passing predictions, and here you have the file name predictions.txt, right, the file name is predictions.txt, right. So, that means this particular line, I mean to say line number 3, that is defining the save underscore predictions method, right, and the 2 arguments, the predictions, right. So, the predictions is nothing but the list of predictions, where every prediction or each prediction is a tuple containing a label, right. This contains label, distribution and probability, right. So, these predictions contain label, distribution and probability, and then file name. So, the name of the file name is right. So, the predictions, right. So, the file name to save the predictions is predictions.txt, right. So, whatever the predictions, that will be saved into predictions.txt, right. So, this is up to line number 3. So, now saving predictions to a file, right. So, here you have the with statement, right, the with statement. So, this is ensuring that the file is closed properly, right, the file is closed properly even if an exception occurs, right, even if there is any exception, right. So, the file is closed properly, and the next line you have for label comma description comma probability, that is what I said, in predictions of 0, right. So, that means this particular line iterates over the first element of, right, the 0th index or the first element of predictions list, which is assumed to be a list of tuples, right. The tuples are label, description and the probability, right. So, this is what line number 5, and finally, line number 6, you have file dot write, right, f description probability, right. So, this is the line writes a formatted string to the file, right. So, the formatted string to the file, you have f2, f etc., right. So, the formatted string will be returned. So, you have the description and the probability. So, this will be returned. So, this is your file handling for saving prediction. So, that means the purpose is it will save the classification results. So, whatever the results that you have got, so that will be saved to a file for the future reference. So, here the key features are, you have a static method, right, the static method. The static method is a save prediction. So, this is writing the prediction to a text file, right, and then output predictions in a human readable format. For example, you have the label, probability, etc., right, the label, probability, all right, and the default file name is predictions.txt, right. So, this is all about your file handling for saving predictions. So, the next one is error handling, right. Suppose if you have an invalid file name or invalid file path, or the file name does not exist, or you have a corrupted image, right. So, you get the image loading errors, right. There is the image loading errors, model errors, the validation, right. But during the loading process, right. So, you have to validate the model loading process, you call it as a model errors, and the prediction error. So, it is managing the invalid inputs to the model, right. So, like a try throw catch in Java or in C++ here, right. So, you are trying to open the image path, right, and then you are trying to store it as an image. So, if you are not able to open, all right. So, if there is any exception, all right. So, these are all the cases, the image loading error, model error or prediction error, or in particular, right. So, this is because you are trying to open this, all right. As usual, what we have studied in Java, suppose you have, all right, any of the errors, all right, then the exception will be thrown, all right. So, the exception will be file not found error, correct. So, that will be printing file not found, all right, and the exception will be as the message, and this particular will be printed, error with the message will be printed, right. It is exactly like what we studied what, all right, in C++, e dot what, it is equivalent to that. So, this is the error handling exception. So, with all, now we are going to main function. So, we have seen so many, right, classes. So, with the help of those classes, we will go to the main function. So, here we import classifier with the help of small c classifier, and file handler with the help of file underscore handler, and line number 4 you have name is equal to main. So, the meaning is this particular line is ensuring that the following code only runs if the script is executed directly, right. So, not when it is imported as a module. So, you got to make sure that is what this particular line number 4, right. So, now here you have image underscore path, right. The image underscore path is test underscore image dot png, right, and then the classifier you are passing this image underscore path, right. So, that means this is creating an instance of the classifier class, right, passing image underscore path, you are passing image underscore path as an argument, all right. So, left hand side you have classifier, and then results, right. The classifier is invoking classify method, right. So, this classify method is on classifier, correct, object to get the results, the classification results. So, up to line number 8 is over. So, now here you have if statement, if is instance of results comma str, that means if the results is a string, right, if it is, right. So, then in that case it is printing the string directly, right. Otherwise, if the result is not a string, right, then it is assuming the 3 tuple, the 3 tuples are label, description and probability, right. So, then it iterates over the first tuple, right. So, you will have a tuple, right. So, let us say I will put some number, right, the label, you have the label, I put L and some description, the probability 0.2 something like that, right. So, that means the first tuple iterates over the first tuple in the list, and it is printing the description and the probability in a formatted string, right. So, that is what exactly it is happening, printf, the print description and probability as a string, right. So, now we are going to save predictions to a file, right. So, the file handler is invoking save underscore predictions, right. So, and it is saving the results, right. So, in fact, it is saving the results in predictions.txt, right. It is saving the results in prediction.txt. So, that you are printing. So, print prediction save to predictions.txt. So, this is about your main program or main function, right. So, this is what we had seen, right. So, in fact, this is useful for the main function is useful for the classification point of view, and it is accepting image path as input, and it is initializing the classifier class to process, right, the image and generate the predictions, all right. So, you have let us say thousands of distributions, right, and then it is taking the top 3 predictions with probabilities, thousands of probability distributions, and you have top 3 predictions of probability, and the file handler, it is saving the predictions to a text file. The text file is nothing but predictions.txt, right. So, with all the classes and the main function, if I run the code, I have to get the output like this. Okay. So, maybe what we can do, we will test this in Python. So, I run the code, all right. So, you can see the output, and finally, it is saying that, right, it is the predictions are saved in predictions.txt, all right. So, I will give the complete code and you can run. So, the standard, you can see this, right, all the numerical values and predictions.txt. So, what we can do, we can open this predictions.txt and you can see, all right, the output, all right. So, this is slightly a harder case study because I just want to introduce the AML concept, all right. So, those who are already familiar, this particular case study will be useful, or otherwise those who have started fresh. So, this will be like a spark, right. So, from here you will get an interest and then you try to run the similar code in Python, right, similar code in deep neural network using Python, right. So, this is what exactly we got similar to this, right, and then it was saved in predictions.txt, right. So, what we can do, the future enhancement, so we can use the multiple image formats, all right. So, any image formats you have to do that, and we can also integrate this with the custom trained models and the graphical user interface for user friendly interactions. So, here we had seen the output, right, the CMD, the command prompt. So, what you can do, you can try the graphical user interface because we have already studied, and there is a concept called batch processing. So, this batch processing, we can handle the multiple images and also the advanced error logging and reporting. So, these also we can think of, right. So, these are all the future enhancements if those who are interested in this particular area or the case study like this. So, in this case study, particularly the image classification tool. So, the main idea is we have developed a modular Python based tool for the image classification, and then we use the pre-trained mobile net model, right. So, we have talked about the mobile net model 224 by 224, and the key components are, I talked about the image loader, right, model manager, the classifications, right, like top 3 classifications out of the 1000 probability distribution. We have also, right, worried about the file handling system because, right. So, you have to save the prediction and also you have to take the input, the file, right, as an image, all right, and then finally we run the main function. So, the features are, so this also can handle the invalid image paths and formats because of the error handling exception, right, and it saves the predictions in a human readable format, all right. So, let us say in fact the 1000 probability distribution. So, from there we could able to predict the top 3, right, with the labels and the probabilities. So, with this I am concluding the case study. The 5th case study is using Python, and in fact in the complete course, right. So, we have covered classes and objects in object oriented programming, and we also talked about the inheritance, right. You also studied polymorphism, and now you know what do you mean by constructors and destructors. We had seen the examples of overloading and overriding. Also, I covered encapsulation and abstractions. So, we have done error handling exceptions. In fact, all the 5 case study, we worked on the error handling exceptions, file handling. This also we have done for all the case study, and we have separately studied. You know what do you mean by templates in C++ and generics in Java, right? And I also covered standard template library. We have also seen design patterns, right? And then finally, we had talked about the advanced topics in multi-threading, network programming, and graphical user interfaces, right? So, apart from all these, we have also worked 5 different case studies using C++, Java, and Python. I hope you have enjoyed the course. Thank you very much.